In stats, we finished up this handout today. Yesterday, we left off introducing Pete's sister Erin, and we found the mean of the total passengers that they've had. Let's see if I can get all this in one page. So we did this part here. We did mu t equals mu x plus mu y, and we got 375 plus 310, which is 6.85. We got that, and then I can't remember exactly how I wrote it, but Pete and Erin's passengers are independent. And that is all because of them living in a different part of the country. Right there. That's what that implies. So when we go to find the standard deviation of the total passengers, we got to square both standard deviations. So 1.0897, 0.943 squared, and we got 2.0767, square rooted that, and we had it. So I think it's important to show all this, even though it was in the last video. And I hope it'll clear up some questions on the next part. So what really happens when you find the standard deviation is you have to square everything, because you're finding how far apart all these values are, and you're not necessarily finding the difference. And so what this is asking down here, to find the difference in their passengers, while we can find it with standard deviation, you end up squaring everything, so you end up adding. The mean is really easy. You just plug in the means. So we're going to go mu x minus mu y, and there's no real problem there. That's pretty easy to handle and makes perfect sense. So the mean total difference, I shouldn't say t, let's change that to a total difference. I don't know, let's get rid of the t. Very confusing, sorry. Is 0.65. So we take 3.1 away. So on average, Pete is having 0.65 more passengers than Erin. For standard deviation, you're supposed to square everything. I wrote that t again, didn't I? So there are coefficients there. There's a 1. And technically, you're supposed to square everything. We just didn't write it on the last problem, because there wasn't a negative. There wasn't any need to write it. So that -1 gets squared, and that's why, in the end, you get the same exact value that we got on the previous question. No change. When we square root it, we still have 1.4411. No change. So that's really important to remember. You are never subtracting standard deviations, even if subtraction is in the function. All right. All right, moving on. Let's look at the money part of Pete and Erin's situation. So we know that Pete is charging $150. Erin charges $175. So what we need to do is write our function for total amount that they collect. So I'm going to write TC this time, is 150 times X plus 175 times Y. And we follow the same pattern. we just plug in the means and we have the total collected mean. Showing every step, that way there is no question. And the mean total collected amount is 1105. For standard deviation, the whole reason why I showed you that previous slide, that previous page, where you square everything is because of this. So we're going to square 150, square sigma x, square 175, square sigma y, and combine them all. I think I have all these numbers memorized now. We've been working this problem for so long. Don't have Aaron's memorized though. 0.943. So for the variance, we end up getting, I actually didn't write that one down. So we are just going to square root that. And we end up getting 232.27. All right. Oh, let's circle that one. What about total collected difference? So same idea. If this is our function, difference between C and G, if we call G how much Aaron collects and C how much Pete collects, we're going to find the mean difference by going 150, 375 minus 175 times 310. And we end up with just $20. Standard deviation, we square everything. So if you need to write it, you can, but I would be A-okay with you just writing no change from the previous, because we square that 175, that negative 175. And we end up with the exact same answer we had a second ago. No change. All right. All right, we have a hard one. I think it's difficult. Last problem. It's about tea, sugar in tea. So I recommend hitting pause and you try and work it without me. All right, here we go. He says it tastes right if it's between 8.5 and 9 grams of sugar. Somewhere between there. This guy puts 4 packets of sugar into his tea. We know that 1 packet is normal with a mean of 2.17 and a standard deviation of 0.08. So what we need to do is write a function based on this one scenario. So if we want to call a total amount T, and that's our function, he puts 4 packets in. So here's 1, 2, 3, and 4. One thing that's really important to do is to write it just like this, because I've seen people mess up the standard deviation if they write it differently. So for example, if they write t equals 4x, it's the reason why that would be bad is because we have 4 individual packets or independent packets. So it's important to write it like that and not as t equals 4x. That'd be like if you were transforming one packet, if you wrote 4x. And right now it appears to be equivalent, 4x versus writing out x plus x plus x plus x. But think about the standard deviation formula. That'll have a different value. So to get the mean of this, we're going to plug in 2.17 and add those up. Obviously, we can get away with just multiplying by 4 for the mean. And we end up getting 8.68. But for the standard deviation, you should give it a try. If you go 4 times x and you plug in the standard deviation, remember you're supposed to square everything since we're talking about individual packets. So this would be 0.08 squared, and you do that 4 times. Now there's another way to write this that would be correct, but I don't want to confuse anyone with what I was saying, so if I were you, I would write it like this. So I know the standard deviation of all of this is 0.16. All right? So we transformed the situation from 1 packet to 4 packets. One thing that's true is this total number of packets is also normal. And they want to know, what is the probability that this guy's tea tastes right? And it's normal, so let's find z-scores, plug it into normal CDF, and we got it. So I did that earlier, and I got negative 1.125. Find this one z-score. And I got 2. Use normal CDF. You don't have to write that, by the way. So that's just for your notes. And we end up saying there is a probability of 0.8470 that his tea tastes correct. It tastes good. So it tastes right, I should say. All right. Have a good one. Bye.